Identification and counting. After extracting Meiofauna organisms from an environmental sample, the following steps are involved in their identification and counting. The sample is first poured over a waste container to remove the formaldehyde under a laminar flow. The storage pot is rinsed with water to ensure all the organisms are poured into the sieve. The sample is washed gently with tap water to remove the residual formaldehyde, being careful not to spill water and lose organisms. Then the sample is placed in a counting grid. A stereomicroscope is used to count, identify and classify Meiofauna organisms to the lowest taxonomic level using identification guides. Organisms can be documented by attaching a camera to the stereomicroscope. Because of their small size, many organisms are mounted on glass slides and analyzed at a microscope to facilitate the identification to species level. These are some of the organisms that can be found in Meiofauna samples. The most common organisms are nematodes and copepods. Nematode slides. Nematodes are the most abundant organisms in marine benthic environments. Proper identification of nematodes requires ensuring that organisms are mounted on glass slides, which helps the preservation of the specimens and their identification to species level. Nematodes are picked and transferred to a glass embryo dish using a fine needle, aiming to collect at least 100 specimens per sample. Degrease solutions. Degrease C1 solution, consisting of 99% formaldehyde and 1% glycerin, is added to the dish. Once the organisms are collected, the cover is removed, and the dish is placed in an exsicator with ethanol. This setup is placed in an oven at 40 degrees overnight. This procedure allows for the evaporation of formaldehyde, which is replaced by ethanol vapors within the exsicator. The next morning, the dish is removed from the exsicator and placed back in the oven. A few drops of Degrease C solution, composed of 95% ethanol and 5% glycerin, are added. Additional drops are added every 2 hours, ensuring that the dish does not overflow nor dry out. This step must be repeated at least 4 times. This process facilitates a gradual evaporation of ethanol and the incorporation of glycerin in nematodes' bodies. Subsequently, Degrease 3 solution is added to the dish, which consists of 50% ethanol and 50% glycerin, then left in the oven until the next morning. It is crucial to ensure that the dish does not dry out, as this could compromise the structural integrity of the nematodes. Slide preparation. Once all the ethanol has evaporated, nematodes are ready to be mounted on glass slides. Microscope slides and cover glasses should be stored in ethanol for at least 24 hours or cleaned with ethanol before use. A paraffin ring is then placed on the microscope slides. For this, a metal tube with 1.5 centimeters of diameter is heated in a flame, dipped in paraffin wax, and pressed onto the center of the microscope slide for a few seconds. A drop of glycerin is placed in the middle of the paraffin ring using an injection needle. Nematodes are then transferred to the glycerin drop one by one, with a maximum of 10 nematodes per slide. The nematodes should be of similar size and thickness and must not overlap. Care must be taken to avoid air bubbles in the glycerin. The glycerin drop with the nematodes is then covered with a cover glass. The cover glass is placed on one side first and then gently lowered to avoid air bubbles. The next step involves heating a metal bridge with a small burner. The microscope slide is placed on the metal bridge to melt the paraffin. It is important not to place the slide too close to the flame. as this could cause the glycerin to boil and form bubbles, which would complicate morphological identification. Finally, the microscope slide is labeled and stored,